Good afternoon. Our presentation topic is deep reinforcement learning and Q learning. What is reinforcement learning? It is a combination of powerful capabilities of a neural network and reinforcement interface that enables agents to learn to behave in different environments. It is a type of machine learning where an agent learns to behave in an environment by trial and error. The agent is rewarded the outcomes and penalized for taking some actions so that it reaches to the desired result. And the components of reinforcement learnings are agent. Uh, it is a entity with that interacts with the environment and based on the understanding of the environment and its goals. The second component is policy network. It is a core component of an agent that is responsible for choosing the next action based on the current state and anything learned from the past experiences. The second component is environment. It is the world in which the agent operates and reward based on its actions. And the there's one more thing, reward function. This defines the agent's objective in the environment and it assigns a numerical reward to each action, indicating the desirability of the action and also help to do some changes in the policy network. So this is the architecture of and the first, the agent begins to observe the current state of the environment, and the policy network takes the current state and predict the optimal or Q function, we can say, and Q function consists of states and action pair. And after choosing one action and a state, uh, the environment through reward function, we take reward and it passes to the policy network. And these loops run again and again until we reach the desired result. Next, we have Q learning, and Sora will present the Q learning.
Okay, so what is Q learning? Q learning is a reinforcement learning technique used in machine learning to teach an agent how to make decisions in an environment. It is often applied in the context of deep reinforcement learning when the state and the action spaces are large and complex. In Q learning, the agent learns a Q value for each state action pair, representing the expected cumulative future rewards of taking an action in a given state. The Q values are updated through iterations based on the agent's experiences in the environment. So let's we have an example like consider a robot learning to navigate a maze. Each cell in the maze is a state, and the robot can take different actions like moving in a certain direction. The Q value for each state action pair represents the expected cumulative rewards. If the robot takes the action in that state, initially the robot does not know the optimal action, so it explores the maze, updating Q values based on the rewards it receives. Over time, it learns which actions lead to higher cumulative rewards, allowing it to navigate the maze more efficiently. This learning process continues until the robot develops a policy that guides its actions to maximize the expected rewards in any given state. So next, we have application that I would like Shikhar to present. So in application like we have robotics. So Q learning is applied, for such as tasks as path planning and navigation in robots. A robot can learn to navigate through environments, avoiding obstacles, and we can using like game playing, where agents learn to play and optimize strategies in games. This includes classic board games, video games, and even more complex games like Go. We can use in like autonomous vehicles. Q learning can be used to train autonomous vehicles to make decision on navigation and obstacle avoidance based on real-time sensor data. Then we can use in like finance, like it can easily predict the a trading, it can do the trading, like it can apply the strategies, optimal strategies for buying and selling financial instruments. And more we can use in different sectors. And the last I would like to say, like in conclusion, to sum it all of, reinforcement learning like q learning is a big deal in AI. It helps machines learn by trial and error, making smart decisions to get the best results. This is super useful in things like robot, games, and finance. It is making machines smarter and more capable. So in the future, they will be really good at figuring things out on their own. So this is the end of our presentation.